Lesson 8.8 in trig on the binomial theorem. We're going to expand. We know how to expand x plus y quantity squared. We know it's x plus y times x plus y. And I'm a box kind of guy, so I usually just leave one of them as the top of the columns, and then I take the other one and I make it the headings of the rows, and then I match things up. So x times x times y, x times y, y times y. And then I add any like terms. And so we would get x squared and 2xy's and a y squared. Now we can continue that process. So for instance, if I were to ask you to expand x plus y to the third, that would be the same thing as x plus y squared times another x plus y. Well, we already know from our previous example right here that x plus y quantity squared is that one. And then if we want to multiply by another one, you just create a larger box. You've got x squared, 2xy, and y squared as the headings of the columns. And then I took this one and I dropped it down the side and made it the headings of the rows. And then I matched up things, x times y squared and 2xy and so on. And then I was able to combine my like terms. And we know how to do that. It's just a bunch of foiling together, that kind of thing. But I want you to notice the coefficients. 1, 3, 3, and 1. 1, 3, 3, 1. Wow, that's kind of familiar. That reminds me of the third row of Pascal's triangle. Well, quite honestly, it is. So the binomial theorem says that you can expand things using combinations, which we know are right there in the good old Pascal's triangle. So let's go back, and I'm gonna redo that question. X plus y raised to the third power, and I'm going to do it a different way. Now this is a little bit different than you'll see in the book, or any of the other math teachers, unless they have chosen to do it the way I like to do it. Well, the first thing I need is the row of Pascal's triangle. This tells me the row of Pascal's triangle that I need. Well, there are two terms here, x and y. So I'm going to start with the first term, and I want to raise it to the highest power, x to the third, and then x squared, and then x to the first, and then x to the 0. And then I'm going to drop straight down from here, right below this, and I'm going to put the second term to the highest power, and then decrease the exponent as I work my way back, y to the 0 being a 1. Now, multiply everything in the individual columns together. And I do mean multiply them together. So I have 1 times x cubed times 1. 3 times x squared times y. 3 times x times y squared. And lastly, 1 times 1 times y cubed. There we go. We've got the expanded form. So, row of Pascal's triangle. First term to the highest power. Count my way down until I get to the 0 power, which would be 1. Slide down. Second term to the highest power, and count my way back until I get to that power to the 0 power, which would be a 1. Multiply down the columns, and you have your term. So let me do one that's a little more complicated. So I need the fourth row of Pascal's triangle. 1, 4, 6, 4, 1. Hey, if you don't know your rows of Pascal's triangle, keep in mind that these are combinations, so we could use 4C0, 4C1, 4C2, 4C3, and 4C4. Okay, so we can use combinations. Let me grab my graphing calculator and show you a quick way to do that. So if you go into your lists, stat, enter, we want the numbers 0, 1, 2, 3, 4. Those are all the combinations that we're going to use for the fourth row of Pascal's triangle. Go up to the top of list 2 and we're going to type 4. Then we're going to use the NCR feature. Remember how we go to the math button and then PRB and then NCR. And that'll put me back on I'm still on list 2. And the values that I want in here are from list 1. So once I've typed 4 and then NCR and then list 1 and hit enter, it'll calculate the row of Pascal's triangle that I need. So that might come in handy. So once I've got the row of Pascal's triangle that I need, I'm going to be working with 2v, which is my first term, to the highest power, and 2v, and I'm counting my powers down. 2v to the 0 is just 1. And I come down from that. Now my second term is negative 3y. Not positive 3y, but negative 3y. So that makes a difference. And I use parentheses because they will come in handy here in a little bit. And I'm counting my way backwards. Negative 3y to the 0 is just 1. I'm going to multiply everything down that column. I've got 1. I've got 2 to the 4th, v to the 4th, times 1. That's 16v to the 4th. Yes, that 2 also gets raised to the 4th power. I have 2 cubed here, that's 8. 8 times negative 3 is negative 24. And negative 24 times 4 is negative 96. So we have negative 96v to the 3rd and a y. Then I've got 2 squared, which is 4. Negative 3 squared, which is 9. And then I have a 6 up here. So 4 times 9 times 6, which gives me 216. Don't forget we have a v squared and a y squared. I have a 2 times 4 times negative 3 to the 3rd. Yes, I'm going to use parentheses, right? A 2 and a 4. You can even see that. And a negative 3 to the 3rd. I get negative 216. Whoops, can't even write. Vy to the 3rd. And my last term involves negative 3 to the 4th power. And that is positive 81. And we just have y to the 4th. We don't have any v powers of v in that last term. So there's your final answer for all of that stuff. We can use this also with an example like this. A coin is flipped 5 times. How many of the possible outcomes have at least 2 heads? We can do it by using this and expanding h plus t to the 5th. Because h plus t, those are the only 2 possibilities, heads and tails. Well, if we use, now if we're going to use our list feature in our calculator, we're going to have to change this to a 5 right there at the bottom because it goes from 0 to 5. And I'm going to have to go back up here and do this again. 5, math button, NCR. Sorry, I did that really quickly. Let me try that again. 5. Math. Probability. NCR. List 1. And there's that row of Pascal's triangle that I need. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. We've got h to the 5th, h to the 4th, h to the 3rd, h to the 2nd, h to the 1st, h to the 0, t to the 5th, t to the 4th, t to the 3rd, t to the 2nd, t to the 1st, t to the 0. Now, honestly, I've done more work than I probably need to. It says, how many of the possible outcomes have at least 2 heads? Well, we know that there are 2 to the 5th possible outcomes. That's the sum of the 5th row of Pascal's triangle, and we know it's 2 to the nth power. So there's 32 possibilities, but this is what I'm really looking at, because it says have at least 2 heads. At least 2 heads, that would be this one, this one, this one, and this one. How many are there? 1 plus 5 plus 10 plus 10. That looks like 26. Now, how could I have used these 2 right here to answer the question? Well, these are the ones I don't want. 5 plus 1 makes 6, and if I had taken that away from 32, I would have had my answer of 26. Now, there's a question. It says, find the 13th term in 2x plus 3y to the 14th power. Well, I want you to go back and remember what we did a few minutes ago on expanding x plus y to the 3rd. Remember, we needed the 3rd row of Pascal's triangle, and then we started with the highest power of x, counted our way down, and then we dropped down and started with our highest power of y and counted our way back. Well, I want you to look. This is the first term. How does it relate to this number right here? This is the second term. How does it relate to this number? Remember, these are the combinations. 3 combinations choose 0. 3 combinations choose 1. 3 combinations choose 2. That's the third term. How does it relate to the 2, the 4 term? How does it relate to the 3? It's always 1 less than the name of the term. We've talked about that in the last section. So if you wanted to find the 3rd term in that expanded form, right? 2x plus 3y to the 14th. I do not want to go through the process of expanding that. I don't want the 14th row of Pascal's triangle. I don't want to go through all that and headache. It's too big. So let's think about this. If I'm looking for the 3rd term, that would be 14 combinations choose 2, right? Because it's always 1 less. 1 less than name of the term. Since we were looking for the 3rd term, we know we're going to have a power of 2x and a power of 3y. We just need to find out what the exponents are. Maybe we should go back up and look at our example again, see how they relate to. How does this one relate to the exponent here? How does this one relate to the exponent here? The exponent on the 2nd term. Always on the 2nd term. Well, what you should see is that they match. Right? 0, 0. 1, 1. 2, 2. 3, 3. So in other words, I should automatically know what the exponent on this one is. Sure, it's a 2. Those 2 should match. Now, what did the exponents add up to? Well, go back to your example. You've got 3 and 0. 1 and 2, 1 and 2, 3 and 0. They add up to the power every time. 3, 3, 3, 3. Well, so all of these should add up to 14. So these two have to add up to rho, or add up to the power that you're dealing with. So this one has to be a 12. So I really need to figure out what 14 C2 is. Well, it's 91. I have 2 to the 12th power, and I have 3 to the 2nd power. By the way, the 91 is from the combination. And then I'll have x to the 12th, y to the 2nd. So I can figure out what this stuff is. 91 times 2 to the 12th. So we ended up with, when we multiplied all that stuff together, 3,354,624. And of course we have our x to the 12th and our y to the 2nd. So use that little trick there, right? This is always one less than the name of the term. This one matches the second exponent, and these two have to add up to the power or the rho that you're dealing with.